Welcome, everyone. I'm excited to kick off our journey today with a look at exploring the power and beauty of nature. On this first slide, we have the captivating title Volcanoes, Earth's fiery heart. Over the next few minutes, we'll dive into the incredible power of volcanoes, their role in shaping our planet, and the stunning beauty they can create. So let's get started and explore the fiery heart of our Earth together. So, a volcano is formed from explosions or the collapse of a volcanic vent. These create steep-sided, circular depressions known as craters. A crater is essentially the opening at the top of a volcano where eruptions occur. Now, let's talk about magma and lava, which are closely related but differ based on where they are in the process. Magma is molten rock deep inside the Earth, and it becomes lava once it reaches the surface during an eruption. When we say magma vs lava, we're highlighting that magma is underground, and lava is what flows out during an eruption. An active volcano is one that has erupted recently or is erupting now. It acts as an outlet for molten rock, ash, and gases, allowing these materials to escape from beneath the Earth's surface through a vent in the crust. Understanding these key points helps us grasp how volcanoes form and function as powerful natural features of our planet. Let's take a closer look at where volcanoes are typically found. They're often located along the edges of tectonic plates, where these huge sections of the Earth's lithosphere are slowly but constantly moving. This movement creates the perfect conditions for volcanic activity. In fact, about half of all the world's volcanoes are part of the Pacific Ring of Fire. This is a horseshoe-shaped zone that encircles the Pacific Ocean and is known for its high volcanic activity. It's a key area to remember when studying volcanoes because it highlights how geological processes at plate boundaries directly influence volcanic formation. Connecting this to our overall theme, it shows us how Earth's dynamic crust shapes natural phenomena like volcanic eruptions. The Pacific Ring of Fire is shaped like a horseshoe and actually extends all around the entire Pacific Ocean basin. It's really fascinating because this shape isn't just a visual feature. It's closely linked to the activity happening beneath the Earth's surface. In fact, about 3/4 of the world's active volcanoes are located here, making it the most volcanically active region on our planet. That's a huge concentration of volcanic activity, which clearly shows how dynamic and restless this area is. This intense activity is directly connected to plate tectonics, the movement of Earth's tectonic plates. As these plates shift and interact around the Pacific Ocean basin, they create the conditions for earthquakes and eruptions. So, the Ring of Fire isn't just a random pattern. It's the result of these powerful geological processes at work beneath our feet. In essence, the Ring of Fire is a major zone where lots of seismic and volcanic activity happen. It's a critical part of understanding Earth's dynamic nature, and it ties into the broader theme of how our planet constantly changes and evolves through tectonic activity. Let's take a closer look at the Hawaiian Islands, which are some of the largest volcanoes in the world. These volcanoes are interesting because their eruptions are typically non-explosive, especially unless water interacts with the lava. This means they tend to produce gentle, flowing eruptions rather than violent explosions. Because of this, they can develop broad, gentle slopes, giving them their characteristic shield-like shape, kind of like a warrior's shield. The lava involved here is called basaltic lava, which is very fluid and flows easily. Basaltic lava is a dark volcanic rock that's rich in silica, iron, and magnesium. Its composition allows it to flow smoothly across the landscape, building up these wide and gentle slopes over time. So, when we talk about shield volcanoes, we're referring to these broad, gently sloping structures formed mainly by basaltic lava, which flows easily and creates the iconic shape we see in volcanic landscapes like the Hawaiian Islands. So this slide shows how cinder cones form, creating a distinctive cone shape as material accumulates around the vent. The eruption style here is brief and explosive, which means it happens quickly and with a lot of force. This type of eruption ejects chunks of sticky lava and ash high into the air. We call this Strombolian eruptions, named after the volcano Stromboli, which is a classic example. These eruptions are formed by fragments of rock and ash that are blasted out during the event. These fragments, known as volcanic cinders, are made of volcanic material that stands out quite clearly from the surrounding landscape. Because of their small size and steep-sided shape, these cones are usually quite noticeable. We classify these as Type 2, cinder cones. They're characterized by their small, steep profile, making them a striking feature in volcanic landscapes. This process illustrates how such explosive activity contributes to the diversity of volcanic landforms we see around the world. In Japan, we have a very famous stratovolcano, Mount Fuji. This type of volcano is a classic example of a composite volcano. It's characterized by its steep-sided symmetrical cone shape, which makes it quite iconic. The eruption style of stratovolcanoes tends to be highly explosive because they often have a lot of trapped gases that build up pressure. When these gases are released suddenly, they can cause violent eruptions, including ash clouds, pyroclastic flows, and even mud flows or lahars. These lahars are particularly dangerous because they can flow quickly down the slopes, causing destruction far from the volcano itself. The composition of these volcanoes is usually made up of alternating layers of lava and pyroclastic material. This layering creates a thick, viscous structure that moves more slowly, but can build up significant height over time. So, in summary, Mount Fuji exemplifies the key features of a stratovolcano: its shape, explosive eruption style, and layered composition, making it a quintessential example of this type of volcano. Now, let's look at the characteristics of Icelandic eruptions. These eruptions are often described as gentle giants because of their relatively calm and steady nature. They produce flowing, gentle lava that moves smoothly across the landscape. This type of eruption typically creates cone-shaped volcanoes, which are quite iconic. While similar to other eruption styles, Icelandic eruptions tend to be more concentrated around a central vent, meaning the lava mainly flows out from one main opening. This results in a more predictable and less explosive activity, which is a key aspect of their gentle character. Understanding these differences helps us see how each eruption style shapes the landscape in unique ways. Now, moving on to Vulcanian eruptions, which are characterized by violent explosions and high-altitude ash columns. These eruptions typically form stratovolcanoes, which are the classic, steep-sided volcanoes many of us picture. During these events, ash, steam, and sticky lava are propelled kilometers into the air, creating dramatic and powerful displays. They are more intense than Strombolian eruptions, with a greater explosive force that can cause significant ash fall and pyroclastic activity. For example, the volcano Stromboli in Italy is a well-known case. It erupts approximately every 20 minutes, showcasing this style of eruption regularly. These eruptions often form cinder cones, smaller volcanoes built from ejected volcanic rocks. The ejected material includes sticky lava chunks, gases, and ash, all released in a brief, explosive burst. Overall, Vulcanian eruptions are a key part of understanding volcanic activity because they represent a more powerful, explosive phase that can have substantial local impacts. Now, let's look at some of the most powerful eruption styles, known as catastrophic events. First, we have the Plinian eruptions. A classic example is Mount Vesuvius in 79 AD, which buried the city of Pompeii under about 6 meters of ash. These eruptions produce ash plumes that can reach over 20 kilometers high, making them some of the most spectacular and destructive volcanic events. They are characterized by their towering ash columns and widespread ashfall. Moving on, another extreme eruption style is the Pelian eruption. A notable example is Mount Pelée in 1902, which tragically killed around 29,000 people in a single catastrophic event. Pelian eruptions are known for their pyroclastic flows, hot, fast-moving clouds of ash and gas that race down the slopes, and their intense heat, which makes them incredibly destructive. Both these types of eruptions remind us of the immense power and potential danger inherent in volcanic activity, emphasizing the importance of understanding these catastrophic events within the broader context of volcanic hazards. Let's take a moment to review the different types of volcanoes and their characteristics. First, the stratovolcano, which is known for its highly explosive eruptions and layered structure. These volcanoes can produce powerful eruptions that alternate between lava flows and ash, creating a classic, stratified appearance. Next, the cinder cone. These are smaller volcanoes with steep sides, formed from sticky lava fragments called cinders or volcanic rocks. They tend to be relatively simple and quick to form, often appearing after volcanic activity. Finally, the shield volcano, which is characterized by broad, gentle slopes. These volcanoes usually have non-explosive eruptions, with lava flowing smoothly and covering large areas. They look like shields from above, hence the name. Now, matching these descriptions to their characteristics, the shield volcano corresponds to the broad, gentle slopes and non-explosive eruptions. The cinder cone matches the small, steep-sided shape built from erupting cinders, and the stratovolcano fits the profile of highly explosive eruptions with layered deposits. Moving on, do you remember the term for the fast-moving, destructive flow of hot gases, ash, and rocks? That, called a pyroclastic flow, and it's one of the most dangerous aspects of volcanic eruptions. Also, about the Pacific Ring of Fire, it's a region where about half of the world's volcanoes are located. This area is particularly active due to tectonic plate movements around the Pacific Plate. Finally, when molten rock is deep inside the Earth, we call it magma. Once it reaches the surface and erupts, it's known as lava. This change from magma to lava is a fundamental concept in understanding volcanic activity. That wraps up our review of these key points. Keep these concepts in mind as they are essential to understanding the different types of volcanoes and their behaviors. So, let's think about your home and the risks that might be nearby. One important thing to know is how to locate the nearest active volcano. Knowing its position helps you stay alert and prepared in case of any activity. Active volcanoes are dangerous because they can erupt suddenly, releasing lava, ash, and gases that can threaten life and property. That's why understanding why a volcano is active is so crucial. It's often related to the movement of magma beneath the surface. Now, you might have heard the term lahar. A lahar is a dangerous volcanic mudflow or debris flow that moves quickly down the slopes of a volcano, especially during or after an eruption. It can cause massive destruction, so recognizing the warning signs is essential for safety. Also, it's helpful to know the difference between dormant and extinct volcanoes. Dormant volcanoes are those that haven't erupted in a long time but could erupt again in the future. Extinct volcanoes, on the other hand, are considered dead. They haven't erupted for thousands of years and are unlikely to erupt again. As you explore more, remember that understanding these differences and risks helps you stay informed and safe. Thank you for your attention, and I hope this information encourages you to stay vigilant and prepared in volcanic regions.